Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid, all because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system. So, theoretically, humans can survive an asteroid that has the potential to destroy entire planets. It won't be a walk in the park, though. Let's go back in time to 66 million years ago, in the late Cretaceous period. The Earth, before humans, where dinosaurs are thriving. The plants and animals are rich and diverse. You'd see a T-Rex chasing a Triceratops, or the massive Alamosaurus, one of the biggest animals to ever roam the planet, towering over the landscape. In Texas, they remember the Alamosaurus. And watch out for the Ankylosaurus, a living tank swinging its tail like a wrecking ball at any threat. As you're about to enjoy a quiet evening under the stars, a bright new light appears in the sky of the northern hemisphere. Now, a new star in the sky doesn't really stand out at first. It's just twinkling like the rest. But give it a few hours and you'll notice it's getting brighter. Check again the next night and boom, it's the brightest thing in the sky, outshining planets and even the moon. Then finally, it horrifyingly outshines the sun. The star was the Chicxulub asteroid, which left a gigantic crater now called Chicxulub Crater in Mexico's Yucatan Peninsula. The asteroid enters the Earth's atmosphere at a blistering 12.5 miles per second. It blasts through 60 miles of the atmosphere in about 3 seconds. It falls so fast that even the air can't get out of its way. The air gets squashed and heats up to thousands of degrees in a blink. Before the asteroid even touches the ground, this super-hot air has already vaporized much of the sea where it's about to strike, near the Yucatan Peninsula. Then, in a flash, the asteroid smashes into the Earth, screaming over Central America with a loud boom that echoes everywhere. It doesn't just smash the ground, it makes the soil and rock flow like liquid. The asteroid digs a hole so wide and deep that it nearly touches Earth's inner layers and throws up dirt more than 20 miles high. At that exact moment of impact, the asteroid also turns its massive speed and weight into heat in a split second. It puts so much energy into the Earth that it makes molecules move faster than the surface of the Sun. This massive energy created a giant ball of plasma, superhot charged gas that includes bits of vaporized rock. This all shot out at incredible speeds. The shockwave from the impact and the heat turned the Earth around the crash site into gas instantly. This set off earthquakes all around the world. And it's not just the rocks flying around that you need to worry about. As they plummet through the sky, they rub against the air, heating up so much that they set fires all around the world. The heat they give off could be compared to an oven cranked up to its highest setting. This fiery shower causes most of the world's trees to burn down. The entire world is now on fire. Soon it changes everything. In a blink, dinosaurs were wiped out, making way for mammals to rise. And not only dinosaurs, 75% of species and big creatures disappeared, leaving behind only some small birds and critters. So, how could you, a human, survive something like that? Now, some animals made it back then. To survive, we need to learn from their resilience. The only birds that survive even in the toughest conditions are the ones nesting safely on the ground. Among the few larger animals that manage to dodge extinction, all have ways to deal with the heat. Some, like certain small mammals, snakes, and lizards, can dig themselves into cooler underground burrows. Others, like crocodiles and turtles, just hide in the water. So, if you're exactly on the other side of the planet when the strike happens, and you act super fast, you might just make it. Right now, the impact is about 10,000 miles away, but don't underestimate its power. As soon as you hear the loud boom, head underground as quickly as you can. And be careful, because you'll feel the Earth shake about 30 minutes later. Hide in a deep cave, preferably with a narrow entrance. It would protect you from the falling debris, and the temperatures underground would be stable. Also, some caves have natural water sources, rivers or streams. You might also prepare for the not-so-great diet of insects, fungi, or poor small animals that also seek refuge in the cave system. But it's better than nothing. You also need to be extremely far away from any large bodies of water. Being near the ocean might seem like a safe bet during a massive asteroid impact because the sea can buffer extreme temperature changes. But the earthquakes trigger terrifying tsunamis, even in lakes or fjords. The asteroid's crash sets off not just one tsunami, but many, and they're as tall as skyscrapers. Within an hour, colossal waves between 600 and 1,000 feet high hit the Gulf Coast, slamming into places like Mexico and the southern United States, and flooding miles inland. These waves are so powerful, they even push rivers backward. These tsunamis continue around coastlines, reaching the east coast of the United States, and 6 hours later, they hit Europe, Africa, and the Mediterranean. By 15 hours after the impact, there isn't a coastline on Earth that hasn't felt the wrath of these waves. Well, let's say you survived the initial impact somewhere deep underground, but your troubles have only begun. The Chicxulub asteroid strikes a region loaded with sulfur. This sends 100 billion tons of sulfur and an enormous amount of water into the sky. The water vapor forms massive storm clouds. They start to rain acid. In colder places, huge snowstorms bury the land under feet of snow each day. The impact also vaporizes massive amounts of oil, throwing up 150 football stadiums worth of it into the air. This oil turns into a thick black soot in the stratosphere. It coats the Earth like black paint. And even when the acid rain calms down, this carbon stays up above the clouds and doesn't wash away. This sooty layer blocks out 90% of sunlight, plunging the Earth into a cold darkness that lasts for at least 3 years. The world cools down by about 50 degrees on average. Now, when you finally leave your deep cave, you must look for places where you won't freeze. The only spots spared from the frost are tropical islands like Madagascar, India, which was an island back then, and Indonesia. These places have surviving plants and animals, and they even continue to get fresh water, unlike most of the world. Everything else in the world looks like a huge nuclear wasteland. These tropical islands are safe spots during an asteroid apocalypse, but don't think of them as paradise. These places still only get about 10% of their usual sunlight and barely enough rain to avoid turning into deserts. In this chilly, gloomy setting, most food chains fall apart. If you want to survive, you'll need to bring lots of extra food with you, for the next 6 years at least. Now, some things are lucky enough to survive. Fossils tell us that freshwater ecosystems did well, so staying close to a river or estuary might be your best shot at finding food. You could come across turtles, crocodiles, and some fish. Animals like clams, snails, and small crustaceans that live in the sediment also manage to hang on. And while a bit warmer than everything else, these places are no walk in the park. You'd need to pack warm clothes to have any chance of survival. Now, if we add all this together, the best spot for surviving the Chicxulub asteroid would be Indonesia. It's a mountainous, tropical country that consists of several islands. There, you'll find bearable temperatures, a bit of rainwater, and a deep cave for shelter. This could protect you from the falling tektites, the intense heat, and even help you find something to eat in the rivers and lakes. But if you stumble upon any shrew-like creatures while scavenging for food, time traveler, please let them be. It's not clear how many survived the Chicxulub impact, and eating one could have unforeseen effects on the future of humanity. Like, don't eat your great-great-great-great-great-great-grandfather, right? What would you do if one day you went outside and saw something bright and greenish in the sky? People around you would be filming the bizarre spot of light nearing the planet. This space wanderer, similar to a falling star, would be getting closer and closer. A comet. What would you feel? Panic? Luckily, there's no need. Even though you can see this comet from Earth with the unaided eyes, it's not going to destroy Earth. Comet Pon Brooks is no danger to us. It's a short-orbit space body orbiting the Sun every 71.2 years. In fact, any comet with a period less than 200 years is considered short period. Astronomers have known about Pon Brooks since 1812, but in the past, the observations of the comet weren't precise enough to predict when or where it would come back. That's why the comet was kind of rediscovered in 1883 by William Brooks, hence the name. But wait, look at the comet more attentively. Are those horns? Yep, and this weird feature caused people to give this space body a nickname, the Devil Comet. In late July 2023, the comet experienced an outburst, blowing off a bunch of dust and gas and brightening around 100 times. Such outbursts are unpredictable, random, and not really common for comets. The outburst made the coma, the freely escaping atmosphere around the nucleus of a comet, forming when it comes close to the Sun, distort into a horned or horseshoe shape. This shape has a dark center and bright wings. After the outburst, the comet settled down again. Its brightness has been steady for some time until it outburst once more. And guess what? The horns appeared again. Astronomers aren't completely sure what might cause the horns, but they believe it could be the fact that the comet spews gas and dust unevenly. One area of the surface that isn't blowing off steam remains dark, and the areas to either side of it are bright. It might also be a shadow effect. The denser material at the center of the comet seems to block some of the bright material behind it from our point of view. Astronomers claim that the comet itself is likely to be bigger than Everest. Of course, it's hard to figure out the size of a comet without observing it directly via a spacecraft or radar. But base it on its brightness, its nucleus, the chunk of rock and ice making up the body of the comet, might be a bit more than 10 miles across. It's even bigger than Everest. The seas might actually be overestimated since the method used for this analysis doesn't allow us to tell exactly where the nucleus stops and the coma begins. Now, let's figure out whether this horned beast presents any actual danger to Earth. Well, it is heading our way. Kinda. You see, Pon Brooks can indeed come pretty close to Earth, and still, the comet isn't as close to us as Venus. When the Devil Comet comes into and then flies out of the solar system, and one might think it must cross the orbit of Earth to get there, but it doesn't. The thing is, space is three-dimensional, and while the planets of the solar system orbit the Sun in a flat plane, comets don't usually follow the same rules. Pon Brooks has a very inclined orbit, bringing it down from above the plane in which the planets orbit when it rounds the Sun, which means that the comet in question passes between the orbits of Earth on the outside and Venus on the inside before heading out of the inner solar system. In other words, there's no threat of a collision whatsoever. By the way, Pon Brooks could be seen during the total solar eclipse on the 8th of April 2024. The Space Wanderer was approaching its closest point to the Sun in its orbit and was bright enough to see with binoculars.
Living on our beautiful planet might seem safe, but only until you start thinking of all those dangers lurking just around the corner or in the vast darkness of the cosmos. Let's see what may eventually lead to the end of planet Earth. With each new potential threat, it gets more and more terrifying. Consider yourself warned. First of all, let's talk about hypercane. This natural disaster can get really extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or a massive volcanic eruption could trigger it. In any case, these conditions would create a hurricane, which, unlike regular hurricanes, would stretch way beyond the lower stratosphere. The speed of such a storm would reach 500 miles per hour. The pressure inside the hypercane would be so low that it wouldn't let it wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It would likely damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Then we've got super destructive tornadoes. A tornado is a violently rotating column of air. It usually extends from a thunderstorm and is in contact with the ground. Inside a thundercloud, warm, humid air rises upward, and cool air falls down along with rain or hail. Such conditions can lead to the appearance of spinning air currents inside the cloud. Interestingly, these air currents start out horizontal, but at one point they can become vertical and drop down from the cloud, becoming a tornado. Some tornadoes are narrow, rope-like swirls, but others turn into wild funnels. Tornadoes are ranked with the help of the enhanced Fujita scale. A weak tornado normally lasts for a few minutes and doesn't move faster than 100 miles per hour. The next level is a strong tornado. Such whirlwinds can last for 20 minutes or so and have winds of up to 200 miles per hour. And then we can also have violent tornadoes. Those can last for more than an hour and move at a speed of between 200 and 300 miles per hour. On average, around 1,000 tornadoes occur in the USA every year. There's even a region that got named Tornado Alley. It's a 10-state area in the Midwest, but tornadoes can happen in any state. One of the most destructive natural disasters was the tri-state tornado in the USA. It was the world's longest-lasting single tornado that traveled 220 miles through Missouri, Illinois, and Indiana. At the same time, the average tornado's path is usually no longer than 5 miles. But what if one day, a tornado much bigger and way more powerful than any we've experienced before swiped through countries and continents? It would leave behind total destruction and devastation. And how about a supercell thunderstorm? It's the least common type of thunderstorm, but it's the most dangerous. It's likely to cause severe weather, damaging winds, very large hail, and even violent tornadoes. What makes supercells unique is a deep and persistent rotating updraft called a mesocyclone. Supercells can potentially last for hours and cause great havoc. An asteroid impact could end all forms of life on Earth too. If a space wanderer was large enough, it could cause widespread devastation, like it happened with the 9-mile-wide asteroid from 66 million years ago. It's rumored to have destroyed 3/4 of the planet's plant and animal species, including dinosaurs. Depending on the asteroid's size and the speed of its approach, the impact could lead to massive fires, tsunamis, and the eternal winter effect. It happens when the debris ejected into the atmosphere blocks sunlight and disrupts the global climate. Luckily, we'd probably notice such a large asteroid coming close to our planet with the help of our equipment long before the collision and would have enough time to get rid of this threat. It would be our very own sun that would bring our world to an end. Our star is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. Now, if you had gamma-ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, and then disappear again. Those flashes are gamma-ray bursts. One of them could wipe out Earth's atmosphere. The flash that might ruin our planet would most probably be born in a faraway galaxy during a merge of two collapsing stars. It would be immensely powerful and super bright. Still 1,000 light-years from Earth, it'd already shine as bright as the sun. Our planet's atmosphere would try to protect us, but its natural shield wouldn't last. The radiation would be so powerful that it would literally cook the atmosphere. It would create nitrogen oxides that would destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun would be hitting Earth's surface at full force. They would wipe out tiny plankton in the ocean. But these plankton produce from 50 to 70% of all oxygen in the world. So, with their disappearance, there would be a severe lack of oxygen, which would lead to the disappearance of life on the planet. In the end, the heat and ultraviolet light coming from the sun would turn the planet into a huge chunk of rock. And what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest to us black hole is 1,500 light-years away. It seems that we have nothing to worry about until we learn about wandering black holes. Now, things definitely get way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2020, 13 wandering black holes were spotted not so far away from our planet. But not far away in space terms means around 1 billion light-years away, so we've got some time left. Plus, the possibility of such a disaster is very, very low. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. Then, the climate all over the planet would start getting colder and colder. Don't forget that the farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Or the sun might expand and turn into a red giant. If it happened, it would change the entire habitable zone of our solar system. The disaster would start with our star running out of hydrogen in its core. This would trigger a chain of reactions, which would eventually lead to the core of the Sun heating up and getting denser. As a result, the Sun would get way larger than it is now. During this transformation, the Sun would swallow Venus, Mercury, and Earth.
Now, are there real-life space monsters? Well, of course, there are no huge beasts made of stars that are flying through the universe. However, there are some things in space that truly remind us of things from our nightmares. The first one is the Eagle Nebula, also known as Messier 16 or Star Queen Nebula, a wonder located in the constellation Serpens. This dazzling nebula was discovered in the 17th century and earned its nickname from the visual impression it creates. If you look at it, it resembles a giant eagle flying through the universe. It's a young star cluster, located super far away, about 5,700 light-years away from Earth. The Eagle Nebula spans a region of about 70 by 50 light-years in size. For comparison, our entire solar system is only 2 light-years long, with the distance between the Sun and Pluto being only around 5 light-hours. This enormous nebula is home to more than 8,000 stars. One of them is especially bright. It's a duo of massive stars, one about 80 times heavier than our Sun. And the nebula is actively creating new ones. Every day, the gas and dust in there are being compressed by the intense radiation and stellar winds from hot, massive stars within the cluster. This triggers the birth of new stars. And finally, in the heart of this nebula lie the iconic Pillars of Creation. These are vast columns of dust and gas seen in blue, red, and green hues. They serve as active stellar nurseries. The dark clouds slowly draw together to birth the stars of the future, shaping the rich and complicated materials found in the universe. Pillars of Creation stretch about 4 to 5 light-years, so about twice as big as our entire solar system. The Eagle Nebula is remarkably interesting to astronomers. It's a wonderful place for us to study the star's birth and evolution. The grandeur of this place is amazing. However, it's more fascinating than frightening, unlike the following monsters. Quasars, captivating powerhouses fueled by supermassive black holes at the heart of galaxies. These black holes are millions to billions of times the Sun's mass. Matter spirals into them, forming a luminous accretion disk. Gravity within generates intense energy across the spectrum, making quasars shine brilliantly. Sometimes they can even outshine entire galaxies. These cosmic monsters have been intriguing astronomers for years. Quasars have the appearance of regular stars, but have incomparable levels of energy. Their name comes from quasi-stellar radio sources. They're radiating across the spectrum: radio waves, visible light, ultraviolet light, X-rays, and gamma rays. We've been catching their signals for many years, but first glimpsed them only in the 1960s. Quasars are one of the most ancient objects in our universe. Their light, traveling billions of light-years, helps us to learn more about the universe's early days when these monsters were aplenty. They gradually dimmed over time, so we can only imagine how brightly they looked back then. One of the most iconic of them is Quasar Colossus. It's not one monster, it's a giant group of 73 quasars. Together, they're spanning 4 billion light-years and outshine 100 million Milky Ways. Something like that is impossible for us to even imagine. Our next monster is called a pulsar. When a big star goes out of its fuel, it goes boom. What's left behind that is a neutron star, which has a mass several times that of our Sun, but crammed into a sphere as small as a city. They're super dense. Sometimes it teams up with some friend, like a companion star. If the companion shares its stuff with a neutron star, things can go wild. The extra material might make the neutron star collapse, becoming even denser. In that case, it would turn into a so-called quark star. But if it doesn't happen, the neutron star goes a different route. This immense density means that the protons and electrons in the star collapse into each other, forming a sea of neutrons, particles without an electric charge. This is when the so-called pulsars are born. Now, pulsars come with an incredible magnetic flare. These stars boast magnetic fields trillions of times more powerful than Earth's. The fun begins when this supermagnetized pulsar starts to spin. It's not a leisurely twirl. Pulsars can rotate hundreds of times per second. They're the fastest objects in the entire universe. As the pulsar whirls around, it shoots out beams of electromagnetic radiation. These beams act like lighthouses, sweeping across the universe with each rotation. If the Earth happens to be in the path of one of those beams, astronomers detect pulses of radiation. That's where the name pulsar comes from. There's someone closely related to pulsars, the zombie stars. Sometimes, even after the star reaches the end of its life and goes supernova, it doesn't fade away entirely. Some matter might remain. In that case, it transforms into a celestial zombie. These zombie stars often appear in pairs, with one star giving in to its smaller companion. It acts like a vampire, feeding on other nearby stars. It drinks up hydrogen to come back to life. When it grows to the size of a planet, it bursts into a brilliant supernova again, destroying the star it fed on. Zombie stars aren't fussy eaters. They go beyond devouring stars. One of them is in the Virgo constellation, and it doesn't just munch on stars. It gobbles up the energy and stuff from its planets. And just like actual zombies are always on the go to find more food, these stars travel through galaxies. Recently, we found another one of them in a faraway galaxy. It's been traveling and evolving over the years, getting brighter. And this show started millions of years ago, back in the age of dinosaurs. Studying them can help us better understand how space objects work in wild conditions. It also helps us reveal secrets about fundamental particles and explore the physics of superdense stellar leftovers. Now that we've met zombies, there are also cosmic vampires. Blue straggler stars defy aging by sucking life from their neighbors. They appear younger and bluer than their ancient companions because of that, confusing poor astronomers about their true age. Scientists studied 21 blue stragglers in a faraway 7 billion-year-old star cluster. That's when they made a breakthrough. They assumed that it was because of mergers or collisions. But then scientists revealed these sneaky stars as thieves, feasting on nearby stars to stay forever young. While this discovery explains most blue stragglers, a few remain mysterious, which means they probably have varied origins. Researchers plan to use the Hubble Space Telescope to detect their hidden companions and learn more about them in the future. Our final monster is an electric Leviathan. In 2011, astronomers stumbled upon a colossal jet spewing out of a galaxy with a funny name, 3C303. It's 2 billion light-years away. What made this discovery truly electrifying was the electric current it carried, an insane 1,018 amps. For comparison, a regular light bulb can barely reach 1 amp. This is equivalent to 1 trillion lightning bolts. This jet, powered by a supermassive black hole at the galaxy's core, extended over 150,000 light-years, surpassing the Milky Way span. This faint galaxy, first observed in the 80s, was hidden from us for a long time. We only discovered it thanks to catching different wavelengths. Typically, jets emerge from galaxies with active supermassive black holes. Only around 10% exhibit matter-spewing jets. The secret to the record-breaking current of this little galaxy lies in the hyperactivity of its black hole. This black hole creates a super robust magnetic field, and this magnetic field creates this electrical Leviathan. So not only do we find the universe's highest electrical current, but it also marked a rare opportunity to study one of these large jets. Scientists keep making their equipment better to study in more detail so we can learn more about them in the future. In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – Panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our Sun, the faster it became, releasing that hydrogen and also changing its path through our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borosa. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borosa before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borosa gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borosa. They found it's throwing off over 400 pounds of dust every second. They also found Borosa has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borosa is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borosa has never interacted with another star.
In 2007, astronomers spotted a massive 54-ton asteroid roaming space relatively close to our planet. But later they lost track of it. That's why the space rock was declared a lost asteroid. Almost 2 decades have passed since then. And in November 2023, a report claimed that the lost asteroid, aka 2007 FT3, might hit Earth in 2024. Such news sounds ominous. But how true is it? Well, NASA disagrees. The U.S. Space Agency has refuted the worrying claims. This statement was issued in response to the announcement that there was a 1 in 11.5 million chance of the asteroid striking our planet on the 5th of October, 2024. The Space Agency states that at any time in the next century, there are no known asteroids that could pose an impact threat to Earth. NASA and other space agencies are watching the skies nonstop, determined to find, track, and categorize asteroids and NEOs near-Earth objects. Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter. But only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects. Inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they might turn into a real threat to the world should a direct collision occur. Luckily, the larger an asteroid is, the easier it is for our planetary defense experts to find it. The orbits of the largest space rocks around the Sun are normally well known and determined for years and even decades. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object reaching 1,610 feet across. It might smash into our planet in 159 years. According to experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If it hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. But even though Bennu's chances of colliding with Earth are quite low at the moment, the space rock has still been categorized as a potentially hazardous asteroid. All because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Asteroid 99942, 942 Apophis, also known under the dramatic name of the God of Chaos, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was still a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years.
If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it is, it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Joukowsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. OSIRIS-APEX will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. OSIRIS-APEX has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare. Uh-oh. Something is nearing the surface of the planet. It looks like a fireball, hurtling closer and closer at a truly incredible speed. Soon, it becomes obvious that the collision is inevitable. Bam! The impact leaves a huge crater. It evaporates thousands of cubic miles of solid rock, and it also sets off a series of terrible natural disasters. Yeah, I know what you're thinking. You believe I'm talking about the catastrophic collision that occurred around 66 million years ago on Earth. You know, the one that's responsible for the extinction of non-avian dinosaurs and 3/4 of other life forms on our planet? But no, the disaster I'm talking about happened on a different planet. Scientists think that our close neighbor, Mars, once experienced the same catastrophe that struck Earth. It happened around 3.4 billion years ago. An asteroid collision might have caused a mega tsunami on the red planet, similar to the one that caused the Chicxulub impact on Earth. Scientists have identified an impact crater on Mars that was probably left by a comet or asteroid collision with the surface of the planet. Most likely, the space body landed in an ocean in the Martian northern lowlands, and the impact was so powerful that it caused a mega tsunami. Before the latest studies, the exact location of the impact crater wasn't verified. It was just a theory. To confirm it, a team of astronomers simulated a comet and asteroid collision in the area where they supposed the impact crater was. They even named this crater Hall. Hall is 68 miles across and lies in a region that is almost 400 feet below the supposed sea level. Anyway, the simulations formed several craters of the same size as Paul. One of the simulations claimed that these craters had been left by a 5-mile-wide asteroid that had encountered strong ground resistance. The other simulation showed that the craters had been caused by a bit smaller asteroid that met a weaker ground resistance. But, according to both simulations, the impact crater was almost 70 miles in diameter, and the collisions produced mega tsunamis up to 900 miles away from the center of the impact site. The simulations also helped scientists estimate the height of the tsunami. It was about 820 feet tall, almost as tall as the Eiffel Tower. The authors of the study also suggest that the Pole crater might be similar to the Chicxulub impact crater on our planet. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This splashdown was so powerful that it left its signature on the entire face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists remodeled the events of the first 10 minutes after the impact, and the models showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. That's like 2 Burj Khalifas, which is the tallest construction in the world, stacked one on top of the other. And of course, all that empty space didn't stay empty for long. The ocean gushed back to fill the crater. But in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. Imagine a 3-story building rushing up to you. No wonder the largest and fastest-moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall, which is taller than the Statue of Liberty, and moved at a speed 10 times greater than more distant tsunami waves. But back to the Red Planet. Some experts think that not 1 but 2 mega tsunamis could happen on Mars. They could be triggered by a pair of meteor impacts that were several millions of years apart. Between these 2 collisions, Mars went through a period of climate changes. As a result, liquid water on its surface turned into ice. In other words, the first asteroid impact most likely produced waves composed of liquid water, and the second tsunami was probably formed by rounded chunks of ice water. By the way, the largest asteroid to have ever crashed into Earth might not actually be the one that ended dinosaurs. A much more catastrophic collision likely happened about 3.5 billion years ago. New evidence scientists found in northwestern Australia suggests that the asteroid I'm talking about was 12 to 18 miles across. It struck Earth at an immense speed, releasing an unimaginable amount of energy. Now, this made me think, what if something like that happened these days? More than 30,000 objects that are circling Earth these days could potentially crash into our planet. NASA considers around 1,500 of them to be potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. For example, in 2004, astronomers discovered a huge asteroid nearing Earth. The first observation showed that the chance of the space rock hitting our planet was less than 3%. The asteroid was named Apus. It's more than 1,200 feet across and weighs about 20 million tons. It's supposed to streak across the sky on April 13, 2029. Apus will pass at a distance of 19,000 miles away from Earth's surface. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 15 years later in 2036. If such an object hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to most life forms getting wiped off the face of the Earth. And it'll probably affect the internet. Now that last thought is truly scary. But luckily, modern technologies are likely to help us avoid any catastrophic consequences. Experts have developed several ways to prevent a real-life disaster movie from happening. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are 3 kinds of missions scientists could prepare at short notice. Type 0, when a heavy spacecraft hurtles toward the intruder with one single goal: to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods work, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that could somehow keep air and water fresh.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the Sun. Bernardinelli Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the Sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli Bernstein is too far away from the Sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the Sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the Sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the Sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the Sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
66 million years ago, I wasn't around then, a huge asteroid hit the Earth and triggered the mass extinction of almost all living creatures on the planet, including dinosaurs. Had the space object crashed somewhere else, some dinosaurs would have been able to survive and still live nowadays. According to some research, the asteroid had about 1 in 10 chances of wiping out the dinosaurs and other animals of that time. It was way more likely to just hit the ground without any strong destructive consequences. To understand how things could have turned out if the place of the collision had occurred elsewhere, we need to find out what happened that day and why the disaster turned out to be so devastating. This huge space rock fell into the coastal area of the Yucatan Peninsula in Mexico. This caused a chain reaction that triggered natural disasters around the world. The place the asteroid hit is called Chicxulub Crater. Now half of this area is underwater. The asteroid was about 7.5 miles in diameter and moving at a speed of 27,000 miles per hour. This rock, bigger than Everest, was rushing toward Earth faster than the speed of sound by almost 40 times. Wow. The energy released in the collision was as powerful as an explosion of about 10 billion atomic bombs, and the destructive force of the blast wave was just one of several disasters. The asteroid happened to fall in one of the worst possible places, and because of the way it fell, it threw a huge amount of dust into the air. Imagine you're jumping into the water like a professional athlete vertically, leaving hardly any splashes behind. And now think of how much water splashes when you jump into the pool like a cannonball. So the asteroid landed the cannonball way. The second disaster the asteroid provoked was soot burning. A small part of the Earth's surface consists of rocks. Only a tiny percentage of that part was rich in oil and sulfur back then. The asteroid burned and lifted so much soot into the air that it would be enough to fill an indoor baseball stadium. According to research, 65 million years ago, only 13% of the surface of the entire planet could have contained the necessary amount of organic material for the formation of such a volume of soot. That's why this place was considered the worst. If the catastrophe had happened on the territory of the other 87%, then dinosaurs would have been alive today. A huge cloud of soot and carbon dioxide rose into the air and covered the sun. The soot turned the sky gray and partially blocked sunlight. This led to a quick drop in temperatures almost all over the planet. It seemed like Earth was inside a gray veil. Many plants and animals couldn't survive the cold snap. Trees began to wither because of the lack of sun. The photosynthesis process was disrupted. The cold and withering of trees led to another catastrophe: global famine. Herbivores couldn't survive because they lost almost all of their food. Plants, flowers, and trees didn't manage to get through the catastrophe. These destructions spread far beyond the asteroid impact site. Hot dust particles, asteroid chunks, and small pieces of rocks settled to the ground across the continent and caused large-scale forest fires. Burning trees threw even more soot into the air, which made the situation even worse. The huge asteroid brought heavy metals with an increased level of toxicity from space. The melting of these substances during the collision provoked firestorms. The asteroid didn't only hit continental land but also water, which triggered a huge tsunami. But that's not the worst part. The seabed was filled with sulfate, and when the energy of the asteroid burned it, it provoked the release of sulfuric acid into the atmosphere. The acid cloud mixed with a cloud of soot and began to spread throughout the sky. Hot rock particles were falling to the ground like fire rain. An acid rain started because of sulfur. It lasted for almost several days and left no chance for the animals to survive. Acid rain made the water in rivers, lakes, and seas poisoned. The acid destroyed anything that couldn't burn. A part of the clouds went to wreck the land, and the other part the ocean. This made the situation even worse, as sulfur droplets wiped out a huge amount of seaweed and phytoplankton. The ocean generates almost half of all oxygen reserves on our planet. Those days, the sea creatures living in its upper parts were destroyed. It wasn't the blast wave, but lack of sun, acid, darkness, and cold that became the main reasons for the extinction of dinosaurs. But even when some lizards escaped from fires and sulfur, they met the sea element. The asteroid impact caused large-scale tsunamis across the planet. The very first wave was around 1 mile in height. That's almost 3 times higher than the Empire State Building. Billions of gallons of water were moving at 90 miles per hour. A wave this strong could easily destroy half of New York today. The meteorite created a series of waves 52 feet high. Massive walls of water the size of 5-story buildings collapsed on the shore and demolished everything in their path. Lack of sunlight, temperature drop, acid and fire rains, reduced oxygen production, forest fires, giant tsunamis, and the explosive wave with the power of 1 billion atomic bombs. All this reduced the biological diversity of Earth by 75%. Yeah, that'll change your climate for sure. Giant asteroids used to hit Earth before, but they never caused such disasters all over the planet. What if this asteroid had fallen into another place, say a forest, far from water and mountainous terrain? This would have caused severe fires. A huge black cloud of ash would have risen into the sky and obscured the sun. But it would have unlikely generated acid or fire rains. Most of the species of the planet could have survived this catastrophe. What if the meteorite had fallen somewhere among the ice and snow? This would have provoked a rapid increase in temperature across the planet. Huge tsunamis would have sunk big tracts of land. However, ash and sulfur dioxide wouldn't have filled the sky. Acid rain wouldn't have hit the ocean. Many marine creatures could have survived and lived to this day. And dinosaurs, far from the oceans, wouldn't have noticed the meteorite fall at all. Probably the most terrible events would have occurred if a meteorite had fallen on an active volcano. This would have triggered the largest lava release in history. Destructive earthquakes would have begun, and the whole sky would have been covered with volcanic ash. What if the meteorite had hit some desert? It would have melted billions of tons of sand and turned it into glass. Just imagine glass dunes that heat our planet even more. And we could dig up the well-preserved remains of ancient lizards out of the glass. Anyway, there were many different possible catastrophic scenarios, and the worst of them came true for the dinosaurs. They are unlikely to return, although perhaps they can be reborn. Scientists were inspired by an idea from a famous Hollywood movie. They wanted to find a mosquito that got stuck in amber. They would extract dinosaur DNA from it. But there was a problem with this. The oldest DNA sample they managed to find was 1 million years old. Dinosaurs were extinct about 66 million years ago. Besides, DNA is a very fragile thing. The probability that it could have been preserved intact somewhere for so long is very small. So, instead of searching for this ancient dinosaur DNA, scientists decided to take DNA from the closest ancestors of these lizards, birds. Over millions of years of evolution, dinosaur paws could have turned into wings, and elongated mouths could have become beaks. Pelicans are very similar to pterodactyls, ostriches resemble velociraptors, and chickens are very much like T-Rex. Okay, let's just stop and imagine for a moment a chicken the size of a T-Rex.
Hey, you want a piece of me?
Now, the common chicken is recognized as the closest relative of the huge lizard. Remove the plumage from it, cover it with scales, give a toothy mouth instead of a beak, and attach a long tail. And you get a real mini Tyrannosaurus rex by body structure and movement. Deep in its DNA, there are similar genes that formidable predators have. With the help of genetic engineering, scientists plan to play with its DNA and try to reverse the evolution, which means breeding dinosaurs can become a reality. Well, that could come back to bite you.
This is it. The end! You're packing up everything you can in whatever bags you have. Food, clothes, toiletries. The news in the background goes on, red alerts flashing all over the screen. You check your watch, and you know it's time. You haven't even finished packing yet. You rush out of your house and see everyone else lugging suitcases hurriedly. You get in your car and drive out as fast as you can, dodging all the people running around. You arrive at a secluded place in the woods. You've been working on your personal bunker for years. It's able to withstand the worst conditions: tornadoes, hurricanes, volcanoes, and, hopefully, asteroids. You run to the bunker, hidden away next to some bushes and trees. There's no way anybody would know it's there. The door looks like the ones in bank vaults that contain huge piles of money. On the other side, a ladder that goes down 30 feet through a dark tunnel. The first thing you do is power up the place. It's all run on heavy-duty batteries, powered from solar panels above. As a backup, a fuel-powered generator. Hopefully you won't need to use it, but your life motto is, a person can't have too many fail-safes. The entire bunker is built from concrete and steel to maintain maximum durability. The walls are several feet thick. You can finally let out that sigh of relief, because you made it just in time. You suddenly feel the ground vibrate, the walls tremble. Fear tightens in your chest when all the cabinet doors shake open and the stored food starts tumbling out. Did you miscalculate? Is this thing gonna hold up? The asteroid made contact, far from where you are, but it feels like it fell right on top of you. The sound is deafening, and the shock waves seem to never end. The light flickers. The flying dust is hazing your vision and filling your lungs. You grab a mask with one final thought. This is it. The bunker's going to collapse. At least I tried. 1 month later. You're making breakfast after another sleepless night. Luckily, you stored more than enough food. And what variety! Canned tuna, corned beef, beans, sardines. Then there's the dried goods: rice, powdered milk, pasta, noodles, and even some treats: honey and chocolate. You also allowed yourself soda and juice, but water makes up most of your stored hydrators. This place has been and will continue to be your home for, who knows, weeks, months, years? The thought sends a chill down your spine. At least you're in an ideal location, far inland and away from any coast, so any possible tidal waves shouldn't have flooded your area. You can't imagine what it looks like up there. Please don't let it be like the dinosaurs Part 2. You need a distraction to take your thoughts away from the worst-case scenario. You walk through your house like a real estate agent giving a tour to potential buyers. At the entrance, you have the living quarters, a couch and coffee table with some outdated magazines and board games. In front of you, a small flat-screen TV with a DVD player. Sadly, no internet, but all those movies should keep you company. On a table nearby, you have a radio and telecommunications speaker that's like your ears and mouth to the outside. You also have your library with all sorts of books. Classics, contemporary, and any genre, as long as it keeps your mind occupied. And if none of that helps you pass the time, there's always the video game consoles linked up to the TV. Ah yes, the gym area. It's modest, just a treadmill and some dumbbells. You try to get plenty of cardio and weightlifting in to keep yourself fit and healthy. Well, for someone living underground like a mole. Of course, you have the kitchen. It's got a good-sized mini-fridge and a stainless steel sink with a bunch of cabinets storing all the goodies. You hook this place up with plumbing and pipes, bringing in clean drinking water. In case those stop working, you have water stored. The bathroom has a functioning toilet, sink, and a shower that's connected to the hot water pump. There's even a washer and dryer nearby. There's also a little workshop area. If something breaks, you can fix it here. You can also build some things out of scrap material, a chair or table if need be, a little figurine to put on the shelf and keep you company. Down some steps, you have another vital piece of the bunker, the greenhouse. It's all on lamps with artificial sunlight for obvious reasons. You'd be way worse off if you didn't have your fresh fruits and veggies. It's all self-sustaining too. Any rotten or bad crops go into making compost for the soil to keep it well nourished. You can forget about relying on meat for protein. Quinoa, beans, lentils, chickpeas, mushrooms, they get the job done. And just in case you're not getting every single mineral your body needs, you manage to stock up on multis. Vitamin D is a big one for life underground without the sun. Not far away from your little subterranean farm is your bedroom. It's got a queen-size bed, nightstand on the right, small wardrobe on the left. You don't have much variety in your attire, but who's gonna notice if you wear the same outfit twice? The dust mites? You go down a ladder to find the generator room. There's a reason why it's further underground and sealed with soundproof material. The generator kicks in every now and then, and it's pretty noisy. It's also hooked up with the ventilation system, so the exhaust goes outside. Then there's the lung room. All these weird-looking boxes are pumps that bring in oxygen from the outside world. But it has an advanced filtration system to clean the air before pumping it into your shelter. Down here is also the storage room. Every spare part of anything goes here. Extra couch, mattress, sinks. Even 2 freezers for those frozen goods, just in case. So, what's a day like in the bunker? First, whip up some breakfast and enjoy a cup of coffee. Then, you head over to the communication radio to hear if there's any news from the outside world. So far, there's been none. As soon as you're done, you head to the greenhouse for some quick farming. You really like being in there because it feels like you're outside enjoying nature. At least a little bit. You pick anything that's ripe and bring it into the kitchen for a wash. And wouldn't you know it, it's lunchtime. You prepare yourself a nice salad of cucumbers, tomatoes, and lettuce. Some beets on the side, pasta, and you eat it up. After lunch, you pop in a DVD you haven't watched in a while. After the movie, you go around and do a quick check on the oxygen levels in water. Today happens to be your scheduled generator checkup as well. You head down to the basement to glance at the fuel level and oxygen filters. All good so far. Though, the thought of an even more extended stay worries you. What if you run out of fuel? You spend a few hours in the workshop tinkering around. Currently, no fixer-upper projects, and you're not feeling especially creative today. So, you head to the gym. Today's leg day. You dread it. Some things never change. Before you know it, it's time for dinner. You heat up some noodles and chill in the living room, listening to some tunes in the music player. This place cost you a little over $100,000, from digging up the site to construction and finally installing all the necessary systems needed for survival. And that's not including the extra food and personal activities for the bunker. Yes, you're lucky. All those luxuries make life good. Almost. Nothing new from the outside world after a whole month. You've always been a bit of an introvert, but this place is starting to push you a little. You're getting lonely. The sound of the radio snaps you out of your thoughts. Static? No, a muffled voice. Someone's trying to contact you. You bolt over to the communication radio, nearly tripping over your own feet from the shock. We made it! Ha! You're overcome with emotion. You've gotten pretty used to your life underground, but it's finally time to swing the door open and head out into the world.
You look up and see a bright orange flash in the sky. A bit later, you hear a boom so loud the window panes around you burst into pieces. And then you see it. A giant piece of space rock burning high above your head, heading for Earth. When it touches the surface, the explosion leaves behind an enormous crater. It's 12 miles deep and as wide as Lake Michigan. After that, 3/4 of all living organisms on our planet are on the edge of survival. This event took place about 66 million years ago, and the bright flash in the sky was the very asteroid that wiped out the dinosaurs. These days, people have many ways to protect themselves, like we could hide in bunkers deep underground and survive. Such bunkers would already come in handy since there are many asteroids in the sky, and some of them are just waiting for their ticket to Earth to wreak some havoc. For example, the asteroid 1990 MU. In 2027, it'll come alarmingly close to our planet. Many people fear that Earth's gravitational pull will trap the rock, which is the size of 2 Brooklyn bridges. In this case, it'll start to move closer and eventually crash into the planet's surface. Such an impact would cause a shock wave that would be felt on other continents. Once the asteroid hit the ground, there would be an explosion. It'd be so bright, people would think a new sun appeared right here on Earth. The collision would release a huge amount of energy that would then turn into heat. Everything around the impact site would catch fire. And if the asteroid fell in the water, it would cause tsunami waves higher than the Empire State Building. Many coastal cities would be flooded. The dust that would rise after the explosion would cover the sun. The world would be plunged into darkness. If the dust stayed in the air long enough, the climate on the planet would change and Earth would start to freeze. If you think such a small meteorite can't cause serious damage, look at the Chelyabinsk meteor. It hit the Earth in the winter of 2013. When the space rock entered the atmosphere, people miles away heard a loud bang. The brightly burning object was approaching the surface at about 11 miles per second. Halfway through the flight, it split into several pieces. This caused several stronger shock waves. When the meteorites hit the ground, it caused a major earthquake, and the aftershock from the explosions shattered the windows of 5,000 buildings. People in 6 cities around the crash site felt the aftereffects of the fall, and this meteorite was only 60 feet wide. Fortunately, the asteroid 1990 MU will move past our planet. We'll be safe. Whew! But the next asteroid to approach Earth is going to be 3 miles wide. It's called 3122 Florence. If this giant hit our planet, it could wipe entire continents off the face of the Earth. In 2017, this space rock got awfully close to us. It could be seen in the sky even with a small telescope. Now, the next asteroid is the biggest one to worry about, 1999 JM8. It's about as wide as Manhattan, and it has an unnerving habit of approaching Earth a bit too close for everyone's liking. A small asteroid named 2020 VT4 got closer to our planet than all others have ever done. In November 2020, it flew over the Pacific Ocean at an altitude a bit smaller than the distance from Los Angeles to Las Vegas. That space rock was about the size of a big car. If it did make it to Earth's atmosphere, it would burn up completely before touching the ground. Falling asteroids and meteorites aren't uncommon on our planet. Luckily, most of them burst into flames and burn up before they enter the atmosphere. Mars is to blame for such frequent meteor showers. The planet isn't far from the main asteroid belt in the solar system. Sometimes, the gravitational pull of the red planet grabs asteroids from there. Then, Mars spins them around and flings them in our direction, just like a slingshot. So, Mars is a bully. Good thing we're protected by Jupiter. It's the largest planet in our solar system, and it has an incredibly strong gravitational field. It keeps the asteroid belt in line and protects us from being constantly hit by a rain of meteorites. And that's good news, considering Ceres is in the asteroid belt. This enormous space rock is so big that it was once considered to be a planet. Then, for many years, scientists called Ceres an asteroid. But in 2006, it was finally classified as a dwarf planet. This space object contains a third of the total mass of the asteroid belt, which is about 4% of the Moon's mass. If Earth were as large as a nickel, Ceres would be about the size of a poppy seed. So, what if an asteroid several miles across was heading toward our planet and people had to stop it? Well, we could break the space rock into smaller pieces. A massive explosion could be used to do this. People wouldn't even need to land on the giant asteroid. Getting close to its surface would be enough. Boom! A powerful burst of energy would split the asteroid into several large pieces and tons of debris. The smallest rocks would burn in the heat released in the blast, and it would also change the asteroid's trajectory. The larger fragments would burn up while entering the atmosphere. All witnesses of this unusual meteor shower would have a chance to admire a beautiful fire show. Another means of protection could be a kinetic battering ram. Simply put, It would be a huge object that people would send towards the asteroid approaching Earth. Or it could be a heavy spaceship. This is the method scientists produced to prevent the asteroid Apus from falling to Earth. This guy is 1,200 feet across and often passes by our planet, coming as close as 19,000 miles above Earth's surface. The asteroid is going to pass close to our planet again in 2029, and there is a possibility that in 3036 it might crash into the Earth. If it happened, the explosion would leave a crater more than 3 miles across. Within 6 miles of the impact zone, all buildings and subway tunnels would be crushed or severely damaged. The event would also trigger a powerful earthquake. In the area of 30 miles away from the crater, car windows and window panes in houses would be shattered. And 75 miles away from the impact site, the earthquake would move furniture and buildings. One way to stop such a catastrophe is to build a heavy spaceship. It would take off from Earth, speed up, and then ram into the asteroid with great force. This impact would alter the course of the huge space rock, and it would fly past our planet. We could also try to stop the asteroid by wrapping it in foil. This would make its surface reflective, and then solar pressure might gradually change the asteroid's trajectory. Another alternative is using the gravitational tug. In this case, we would send an unmanned spaceship, large and heavy, toward the asteroid. It would fly over the space rock and slowly draw the thing closer with its gravitational pull. A small change, of course, would be enough to make the asteroid fly past our planet. Another way to protect Earth would be to build a system of giant lenses in space. Perhaps you've tried focusing sunlight with eyeglass lenses. Then you know how hot this sunlight can get. Now imagine having many giant lenses that are all directed at one point. Scientists think that focusing such a powerful beam of light on the asteroid would make the rock melt and evaporate, slowly changing its route. And one more way to protect ourselves from the asteroid would be to install several rocket engines on its surface. It would turn the space object into a rocket, and we could set its course from Earth. Rogue stars pose a much bigger danger. Like asteroids, they fly through space and can collide with anything in their path. The problem is that they have a gigantic mass, sometimes comparable to our Sun's. Around 70,000 years ago, a duo of rogue stars whooshed past the Sun. It didn't affect Earth, but caused some disturbance on the outskirts of the solar system. This event is likely to happen again someday. The rogue star Gliese 710, about half the mass of our Sun, is moving toward our solar system right now. There's a possibility that it'll begin to grab asteroids from the outer asteroid belt and toss them at us. And then, rare meteor showers you can observe these days will become a regular occurrence. But right now, this rogue star is extremely far from our world, and there's a bigger chance that it'll pass by without affecting our peaceful existence.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under two continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the Moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed two enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges.
It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger. But nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon, and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet. But something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the Moon. This means that the forces holding the Moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The Moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The Moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the Sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The Moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.